In Kerbal space program, when a capsule falls to the planet, it slows down. Let's G-Sci that. Over on the Master Hellish YouTube channel, one viewer asks, why does a small roundish capsule slow down as it falls to the planet? Shouldn't it accelerate? Well, generally, objects falling do so due to the gravity acting upon them, and as they do so, they get faster and faster. If we drop something, at the very moment you let go of the ball, it isn't moving. Previously, the grip that you had upon the ball, causing friction, was stopping it from falling. But when you let go, that friction's no longer there, and gravity takes over. And it falls. And as it does so, it falls faster and faster. You can see this when you throw a ball into the air. It almost seems to hang there before falling back down faster and faster. As things move through the air, they generate drag. You can see this in Kerbal space program. By pressing F12, it shows many of the forces acting upon the craft. This is basically air getting in the way and disturbed around the object. Drag doesn't just affect things which are falling. It's pretty much when anything is moving through something. If you want to experience this for yourself, you can do a little experiment. Go out for a walk down the park, preferably on a day when it's not windy. Pop your hands in your pockets and hold your coat up. Walk between 2 points, and unless it's windy, you probably won't feel too much drag. However, if you run, you will feel lots more drag being caused by the large surface area of your coat. You can also try running with your coat down, and once again you'll notice less drag than when you were running and had your coat up. Doing all this running shows how both your speed and your shape affects the amount of drag which you feel. It also helps burn off the ice cream you had at the park. So as you fall faster and faster, you generate more and more drag. When your drag force equals the force pulling you down due to gravity, you will stop accelerating and fall at a constant speed. This is the object's terminal velocity. But what about our space capsule? Well, it's also falling to the ground, albeit from very high up in space. And that's the important part. It's in space. In space, there is no air to slow it down. As it gets closer to the planet, it encounters the atmosphere, and then that is when it starts to cause drag. In space, it was going well quick, much faster than its terminal velocity would be if it was going through the air. So as the craft enters the atmosphere, it generates drag. This drag force unbalances the force that was pulling it down to the ground, and it starts to slow down. Moving through the air this fast generates a lot of heat, and this heat can be seen as a warm glow as it enters the atmosphere, both in the game and in real life. As the craft slows down, the drag force on it decreases, and eventually that becomes balanced with the force of the gravity pulling it down. When this happens, it stops accelerating and it reaches its terminal velocity. It floats downwards at the same speed. As a bonus, let's have a look at what happens when the parachutes open. A component of the drag force is the shape of the object. Like when we put our coat up in the park earlier, when we increase the surface area, it produces more drag. So when we open the parachutes, this increases the surface area and we have more drag applied to our capsule, and it slows down more. And it slows down until that drag component goes down again and it reaches its new terminal velocity, or the ground. Kerbal Space Program is a fantastic space simulation game with little green men, and I think it's fantastic. It's not exactly the same as real life, the scaling is different, but some of the principles are all there, things like drag and forces and velocities and all that sort of thing. And it's a fantastic way to learn about spacecrafts and how they get them into space and into orbit. Also, it has explosions. So there we have it. On Earth, usually things will fall faster and faster towards the ground, accelerating. However, in space, there is nothing to slow you down, and you don't slow down until you enter the atmosphere. This then slows you down until you reach your terminal velocity or your parachute's open. Hopefully. Thanks for watching. G-Sci.